This basic function precisely expresses the core of the narrative I'm about to tell you today. As x approaches 0, y approaches infinity. Mathematicians refer to this as the singularity point, a value that exceeds finite limitations. Astrophysicists also use this term when a huge star collapses in a supernova explosion. A singularity with zero volume and infinite density occurs at its core. We name this point from which no light can escape a black hole, a tear in the fabric of space-time. And now we are at a similar point in human history. In the coming years, a shift will occur that will drastically alter every area of human life, from sexuality to spirituality, from business models to life cycles, in the same way that a black hole bends space-time. It is a moment when technology transformation will accelerate and have such a deep impact on human life that it will be irreversible. This is not a utopia or a dystopia, rather it is an era in which every notion that gives our life value, even death, will be redefined. In the 1950s, John von Neumann, whom we recently filmed, stated, "The ever-accelerating advance of technology marks such a fundamental singularity in the history of the race that human life as we know it cannot continue after this point." Von Neumann makes two critical observations here: acceleration and singularity. Understanding the current momentum is critical for accurately interpreting the future. Because human growth is exponential, not linear, that is, it is multiplication by a fixed number, rather than addition by a fixed number. And exponential growth is deceptive. It appears virtually undetectable at first, only to burst. Let me illustrate this with a great story. The Indian ruler enjoyed playing chess. One day, a guru appeared and taught the emperor chess. The emperor was so pleased that he said to the sage, "Ask me anything you wish." The sage made the following offer, which appeared to be a very modest request. "I want you to put 1 grain of rice on the first square of the chessboard, 2 on the second, 4 on the third, 8 on the fourth, and twice as many on each square." The emperor laughed when he heard this request. What a simple and humble request it seemed, but his advisors, who knew math, immediately started calculating. The 8x8 chessboard has 64 squares. When we reach the final square, we will require 2 to the power of 63 grains of rice. The total quantity of rice grains is so huge that even the world's rice supply would fall short of meeting demand. This demonstrates the misleading nature of exponential development. Increases that appear innocent at first become unbelievable as they continue exponentially. This is exactly how technological advancement is going, and we are on the verge of the final doubling. Skeptics always point out areas where AI falls short and say, this is where human supremacy will continue, but in the near future, knowledge-based technologies will include not only knowledge, but also pattern recognition, problem-solving skills, and even emotional and moral intelligence. And now we come to a crucial point. Our brain has major limitations. Yes, it works with amazing parallelism. It can make 100 trillion neuron connections at the same moment, but our thinking pace is really slow. Our neural processes are 1 million times slower than electronic circuitry. This greatly inhibits our ability to process new information. Our biological bodies are similarly delicate and require ongoing care. Human intelligence is derivative, trivial, and restricted in its reasoning, while it can occasionally display extraordinary innovation. The singularity will allow us to get beyond these limitations. Our future will be in our own hands. We will have control over our lifespan, which we can extend as long as we like. So we shall fully comprehend human cognition and push its boundaries. By the end of the century, our non-biological intelligence will be trillions of times more potent than human intelligence today. The amazing thing is that despite this degree of expertise, we are still in the early stages of this transformation. The paradigm change and the capability of information technologies are just at the knee of the exponential curve, when the exponential tendency becomes apparent. Following this point, the trend will accelerate dramatically. But let us take a step back and speak about the 6 epochs that Ray Kurzweil discusses in his book, The Singularity is Near, which elegantly outlines how we got here and explains where we are and where we are heading. Each of these epochs represents an important milestone on the way to the singularity. Most critically, each age builds upon the previous age's information processing methods. For example, we can refer to the earliest age of the cosmos as the age of physics and chemistry, because we can trace our lineage back to the most fundamental building blocks. Even basic patterns of matter and energy include information. According to modern quantum theories, even time and space are made up of discrete particles, mostly information particles. It is still unclear whether matter and energy are primarily digital or analog. However, we understand that atomic structures contain and represent distinct information. The first atoms were formed a few 100,000 years after the Big Bang when electrons orbited the nuclei of protons and neutrons. Atoms' electrical nature caused them to stick together. Chemistry emerged a few million years later when atoms bonded to form molecules. Carbon is an extremely significant element. Carbon could bond in 4 directions, but other atoms could only form 1 to 3 bonds. This facilitated the creation of 3-dimensional structures containing complex information. The most intriguing aspect is that our universe's physics rules and the physical constants governing the interaction of fundamental forces are so sensitive and appropriate for the encoding and development of information that we continue to marvel how such an amazing situation could have occurred. Some detect a divine hand in it, while others point to the anthropic principle. That is, we can only ask this question in a universe that evolves in the same way we do. According to current physics theories, new worlds arise on a regular basis, each with its own unique set of rules. However, the majority of these universes are either swiftly dying or do not produce intriguing patterns like ours. That is because their laws prevent the emergence of more complex organisms. The second age is the age of biology and DNA. This era began several billion years ago. Carbon-based molecules grew increasingly complicated. Eventually, groups of molecules developed digital methods for self-replication. We are talking about DNA, which, along with its supporting apparatus of codons and ribosomes, allows us to trace evolutionary trials. The third epoch marked the beginning of the brain age. Each age advanced knowledge to the next degree. Evolution, led by DNA, generated species in the third epoch that could perceive, process, and store information in their own brains and nervous systems. This was made possible by the processes of the second period, such as epigenetic understanding of DNA, and the protein and RNA pieces that regulate gene expression. These techniques indirectly enabled the third epoch's information processing systems, the organism's brains. It also indirectly triggered and characterized the third epoch's information processing mechanisms, specifically primitive animals' ability to identify patterns. This skill remains responsible for the vast majority of our brain activity. Eventually, our own species developed the ability to interpret the world we live in terms of abstract mental models, and to consider the reasonable ramifications of these models. We may rethink the world in our minds and put these concepts into action. When we reach the fourth age, we enter the age of technology. We began the fourth age by merging our rational and abstract thinking abilities with our thumbs. So, the growth of man-made technology began with simple mechanisms, progressed to complicated automated machines, and finally, with powerful computing and communication devices, technology became capable of sensing, storing, and interpreting complex patterns of information. Comparing the evolution of biological intelligence with technology intelligence reveals the following. While the most evolved animals increase 1 cubic centimeter of brain volume every 100,000 years, the processing power of computers is doubling every year. Of course, brain size and computer capability are not the only determinants of intelligence, but they are significant factors. The fifth age marks the intersection of humanity and technology. This is where the singularity begins. The tremendous amount of information stored in our brains is merged with technology, resulting in significantly increased capacity, speed, and ability to communicate knowledge. This is the singularity that will allow human-machine society to surpass the biological brain's 100 trillion sluggish connection limit, allowing us to answer old human questions and greatly improve our creativity. We shall overcome the deep restrictions of biological evolution while retaining and improving the intelligence that evolution has bestowed upon us. However, the singularity will also improve our ability to recognize our destructive tendencies, so the ending of this story is yet to be written. And the sixth age, the reawakening of the universe. In the final age, intelligence drawn from biological origins and human creativity will begin to permeate the matter and energy around us. It will accomplish this by reordering matter and energy, delivering optimal computational performance, and expanding from Earth to the universe. We currently realize that the speed of light is a limiting element in information transport. Breaking this barrier appears very speculative, although some indications suggest that it can be broken. Even little deviations will eventually enable us to use this super light speed capabilities. It is up to us to determine how quickly or slowly civilization instills creativity and intellect throughout the universe. Either way, the universe's non-intelligent matter and machinery will be turned into magnificent forms of intelligence. This will mark the sixth era in the evolution of information patterns. What happens if we plot the main turning moments of both biological evolution and human technological development on a single graph, logarithmically graphing the years on the x-axis and the duration of the paradigm change on the y-axis? A straight line, constant acceleration, a direct transfer from biological evolution to human technical growth, and this is not confined to the events discussed here. When we combine diverse lists, such as encyclopedias and the American Museum of Natural History or Carl Sagan's Cosmic Calendar and other sources, we always find the same smooth acceleration. In these graphs, order and complexity increase exponentially. 1 billion years ago, very little happened in even 1 million years, whereas epochal events like the emergence of our species 250,000 years ago occurred in only 100,000 years. In technology, there was not much that happened in 1,000 years 50,000 years ago, yet new concepts like the internet took only 10 years from their inception to widespread implementation. You also recall the rapid spread of ChatGPT, so we are essentially increasing the rate of paradigm shift every 10 years. The 20th century steadily advanced to today's pace of advancement. At the rate of 2000, the century's accomplishments were comparable to around 20 years of progress. We will now make the same development in 14 years as we did in 7 years. In other words, we will not experience 100 years of technical progress in the 21st century. Rather, we will see 20,000 years of progress at the current rate. That is one time what was accomplished in the 20th century. So, people intuitively assume that the current rate of advancement will continue in the future, and they believe this will happen. From a mathematical standpoint, the reason for this is simple. When observed briefly, the exponential curve appears to be a straight line, but when viewed from a distance, it tells an entirely different tale. Scientists and engineers share a frequent phenomenon known as scientific pessimism. They are, frequently so preoccupied with the technical intricacies of a present difficulty that they lose sight of the long-term ramifications of their own work, as well as the larger picture of the subject in which they work. They also fail to consider the far more powerful tools that will become available with each new generation of technology. Scientists are educated to talk cautiously about current research goals and rarely speculate on future scientific activities. This technique was satisfactory when a generation of science and technology lasted longer than a human generation, but nowadays, a generation of scientific and technological advancement lasts only a few years. So, can the speed of technological growth continue indefinitely? Is not there a point at which people will have difficulty thinking? Yes, there is for undeveloped humans, but what if 1,000 scientists, each 1,000 times brighter and working 1,000 times faster than today's scientists? 1 year for them would be comparable to 1,000 years for us, and this is only the beginning. Because they will develop technology to raise their intellect even further, their intelligence will no longer be confined to a fixed capacity. They will adapt their mental processes to think faster. When scientists become 1 million times smarter and faster, 1 hour will be comparable to a century of progress in today's terms. So the singularity has multiple faces. In actuality, it symbolizes an almost vertical era of exponential expansion, with technology appearing to increase at an endless rate. Mathematically, there are no breakdowns or discontinuities, and the growth rates are finite yet extremely high. However, based on our current worldview, this upcoming event appears to be a dramatic and unexpected interruption in the continuum of progress. Of course, many people are concerned that these changes may result in the loss of an important component of our humanity. However, this viewpoint is based on a misunderstanding of our technology's future potential. All of the machines we have encountered so far lack the essential intricacies of human biological features. The singularity's most significant consequence is that our technology will approach, and eventually surpass, the nuance and adaptability of what we perceive to be the best of human characteristics. It is up to us to play an active role in this journey and create the future. The singularity is unavoidable. The only question is when it will occur and where it will lead us.